Okay. Is it on? Is it on? Yeah. Okay. Hello. I'm Sebastian Damm. I'm working for sipgate, as Daniel said, and today I want to talk about how to get your existing voice over IP service ready for IPv6. As I mentioned, I'm working for sipgate, and I'm sure most of you know what we do and who we are, but for those who don't, yeah, we are a voice over IP service provider based in Düsseldorf. We started off in 2004, started with a private customer product first in Germany, then in the UK. And yeah, added later on business customer product like a hosted PBX solution, then became 3 years ago full MVNO in the E+ network, so we could add some additional mobile services and products to our portfolio. And right now we have a couple 100,000 active users or customers, and each month there are 100 million minutes going through our network. So that's just about us. And what's maybe a bit special about us is that we do everything in-house, and we try to do everything that we can do with open source. We just hate black boxes, and we don't use them if we don't have to. So let's start. This is, for those of you that were here last year, you probably know this slide kind of, because Christian, my colleague, told you about something about the last 10 years, how our system developed, and this is how it looks right now. And on the left side, you see our main Kamailio and load balancers and proxies. And yeah, we are using an Anycast setup, so we have the same IP on each of the load balancers, and that makes us, or that enables us to have just one IP for our service right now. And then all the load balancers dispatch to the relevant proxy, and yeah, from there on we have quite a few asterisk gateways. We use them either for gatewaying or for adding some additional features for the PBX solution. And when it's past those asterisks, then we have like two paths. There are another set of Kamailio processes that we use as load balancers for our interconnection to wholesale partners, and the other path is we have YATE as a soft switch for our connection to the PSTN. And so in combination with some media gateways, we have some SS7 connection there. The problem with all that is it was, or it is, IPv4 only. And for those of you that run bigger networks, they know that there's always that one router that still doesn't speak IPv6. So, of course, the main goal is to have everything IPv6 ready, but that would have taken just too long. So we thought, how could we get there quicker? And what we came up with is we just replaced, or actually added, a load balancer that translates from IPv6 to IPv4. And for audio, we added RTP proxies to it. So this is the call flow. So you see the SIP comes in via IPv6, and that then gets converted to IPv4, gets passed on to the proxy server, and yeah, from there on, it's still the same. And the RTP goes to the RTP proxy and then goes directly to the gateway. What did we have to change? Yeah, we had, of course, add another listening interface to the load balancer. We had to make sure that the correct socket is used when sending out the packets, because when you have multiple IPv4 addresses on it, then you have to tell Kamailio which socket to use. We had to implement handling there because before it was done on the proxy server. And we had to use the registrar module. This is quite a hack, and I'll come back to that later. This is actually the RTP proxy handling. That's the main, that's the route that does everything in there. And in the upper part, you see there's the request part, and we are checking whether it's coming from IPv6 or going to IPv6, and yeah, then if it's coming from IPv6, then we call the RTP proxy manage function. We use the RTP engine from the SIP-wise project, and yeah, with the EI options are from external to internal, and if it's going to IPv6, then we just call it IE. And if it's in a reply, yeah, we have to parse some via headers to check whether it's really a comment from IPv6 or going there. And yeah, then we call the RTP proxy manage function too. Yeah, as I said, we are using the registrar module and the NAT helper module too. And yeah, you probably all heard that everything's going to be easier in IPv6 because there is no NAT. But what they actually didn't tell you is there are home routers in front of most of the devices. And those home routers will prevent connections from outside. And when we turned or set up this our load balancer first and then put the first clients on there, they had this problem that they weren't reachable when they got calls from outside. And we thought, okay, this problem, we know that from NAT scenarios in IPv4, but we thought they should be gone in IPv6, but apparently they aren't. So what we again have to do is we send NAT keep alives. I still call them NAT keep alives, but yeah, like we did in IPv4, that what the registrar or the user log module does. But what's different is this time we don't know which devices we have to send those packets, but we have to send them to every single device registered. Normally, probably the proxy would do it, but since it's not IPv6 capable yet, we are doing it right now on the load balancer, and yeah, that's why we are saving the location when it's passing the load balancer, and then sending it on to the proxy server for the real saving. As I mentioned on the first slide, we are using Anycast, and that means that we have the same IP address on multiple hosts in our network. But there's one problem with it. The MTU can change on the way to the client, and you see there on our side it's still 1,500, the MTU, but back there it's only 576. So what happens when we send out a packet? The router says, oops, fragmentation needed. And since we are using Anycast and it takes the shortest path back to our system, the ISMP response could end up on a different system. And but the sending system doesn't know whether that this ICMP fragmentation needed packet came in, and so it will retransmit the original packet. In IPv4, it was quite easy. You could just turn off path MTU Discovery, so the UDP packets will get sent out without the don't fragment bit, and the router will just fragment those packets, and the recipient will reassemble those packets. In IPv6, that's not allowed anymore. So for the first time since we are offering our services, we had to have more than one IP for our service, so we can still load balance the traffic. And so we have, in our network, we're doing it with OSPF, and we are putting we are still putting those addresses on multiple machines, but we are adding costs to some of them, and so the path in our network is always ends always on the same machine. I know this graph is not correct because the minimum MTU in IPv6 is 1280, so that's that should be there, 1280. Yeah, and when we send out this packet, the ICMP response ends up on the sending system, and the sending system can send out smaller packets again. And then they will end up on the recipient. So what are the things that we stumbled upon when implementing our solution is, yeah, there are two kinds of usage of IPv6 addresses in those packets, and when you use them in the Kamailio config. And yeah, one is the address itself, and then there's the address reference. And the IPOps module gives you two functions, and you have to make sure that you use the correct function, otherwise it won't work as you expect. What we also saw when we put the first beta customers on there is that you can have some clients that have IPv4 addresses in their IPv6 packets, so you have to use the NAT helper module to fix those addresses. When saving IP addresses to the database, be sure that all the bits fit in there. And there are still a lot of readiness issues. Within the first 2 weeks when we started, we found 3 bugs in Kamailio, but Daniel fixed them all within hours. Thanks for that. The capture agent is not yet IPv6 capable, but I guess it will. No, I heard the capture agent version 6 is IPv6 capable. The GeoIP module, we asked for it on the mailing list, and the developer said, oh yeah, I have the GeoIP2 module laying around, but I still have to push it. And then there's a GeoIP2 module right now, and that's v6 capable. And there are quite a few phones or soft phones that don't behave as you expect, and some of them are not v6 ready at all. Like all those decked Gigaset phones, they just aren't v6 ready. Okay, that's this theory, and that's when we turn it up on Monday night. So we just published the Quad A records for our domains, and yeah, that's what happens. You see, there were the beta customers first, and then within really only a few hours, a lot of devices came in there. I actually didn't expect that because a lot of those clients that I examined beforehand and where I wrote some FAQ articles, they all, or a lot of them, needed some reconfiguration, but the clients that I didn't expect were the speed ports that are, at least in Germany, they are pretty widespread, and they were the first that adapted it. And yeah, the SNOM phones, they use it automatically, yeah, and asterisk and some soft phones. And the next day, yeah, we already had like about 1% of our clients on V6 automatically without doing anything. That's actually pretty good, but all those Fritzboxes that are popular in Germany, they need some reconfiguration, and you probably have to guide your customers to get there. Our customer support, they were really anxious about that change. They were afraid that they would get a lot of requests, but what actually happened was nothing. There were some business customers that had their whole office equipped with Bria soft phones. That's something from Counterpath, and when you turn on IPv6 support there, it will send out a V4 and a V6 register, and then we send on incoming calls, we send both invites, and it won't let you answer the call. So that was about the only phone that was not really capable, and that was, at least in our scenario, was relevant. Yeah, but other than that, just worked. And that's already it from me. Yeah, 2 sponsored ads. We have, we are always looking for excellent technicians, and if you are searching, yeah, just stop by our page. And if you're in the Düsseldorf area and you don't know what to do for noon, just stop by. We have this lunch program where we just want to talk with people that have interesting things to say or want to know something about us or from us. Yeah, just sign up there, and then we'll find an appointment there. That's it.
So you see, easy IPv6. I'm coming. I saw one there. We have it since 2002. It just takes 5 minutes to enable.
Question about the home routers. Are they giving out linked local addresses and continuing to do NAT, or are they giving out globally routable IPv6 addresses but preventing outside connections to them? If the latter, then why do you need these NAT pings? Why do you need these keep alives?
Because the clients will start the register from the inside, and then after like 30 or 45 seconds, the firewall will, the hole that has been punched in the firewall will close, and then and so the other way around, our packets won't get through.
I can add to that. This is because people believe that NAT was a security issue. So there's a recommendation from ITF in an RFC to always have a stateless firewall turned on. You can turn it off if you want to, but the recommendation is when switching to IPv6, give the customers the same set of functionality. And that's why we need those keep alives. If you read the RFCs in the SIP outbound RFC, it says that the client is responsible for the keep alives, not the server though. But
yeah, not
this is to resemble the security part of NAT.
Yeah, thanks.
Another question here.
Yes, so from customer side, the IPv6, IPv4 transformation is transparent. So do you see any benefit on making your whole backbone IPv6 capable, or do you think this is a solution for a long time?
Well, I mean, you have this additional RTP hop when the RTP engine has to be in between. And if you have all the way to the gateway IPv6, then the customer can talk directly to the gateway. So that's the main benefit, I think.
Thank you.
I'm invisible behind the pillar, but so what's the situation with the temporary IPv6 addresses that things like iOS generate? How does that, have you hit that problem? Does it turn into an issue? Does it just work?
I've seen those temporary IP addresses. I think even on my Grandstream that I have on my desk, and sometimes at least the Grandstream puts the temporary address in the contact header, but sends out the packets through the real address. And so
That's a bug.
Yeah, of course it is. But that's what NAT helper helps you get rid of.
Okay, let's.
Hello. Did I understand it right that you only talk IPv6 to your gateway?
Right now, yeah, that's true.
Planned feature?
Yeah, of course. But that was the first step because the pain was high enough. And yeah.
Pain, IPv6. Oh.
Hi. Do you use TLS, and was there anything worth mentioning with TLS over IPv6?
Right now we have still only UDP services, but we have been playing with TLS and are using it in our office but that's only v4 right now.
One for me might have been mentioned, but I noticed that some IP in Germany automatically switch it to IPv6 silently. Have you been hit by that? Somehow, knowing that a lot of your customers are using their devices.
Of course. That's what made the pain growing over the last year because those cable providers, were either switching their customers to v6 and then only those DS Lite solution for v4, and yeah, that didn't really work really good.
And my question is, after having these customers on IPv6, was there a higher support request volume? I mean, you made your platform, and after it was tested, are more problems with IPv6 customers or with IPv4 customers?
It's gotten less.
Yeah. Okay.
Yeah.
So it's painless.
Before,
after a while.
yeah, it really was painless. I actually didn't expect that, and I thought, okay, we turned it on Monday night, and then came to work early on Tuesday, and was expecting to find some problems or having to look for problems, but I checked a lot of calls and they all went through, and customers were reachable when being called and looked all good. And from customer support, I didn't hear anything.
Perfect. Okay, thank you, Sebastian. Thank you for sharing